Okay, this lesson we're looking at Unit 6, Chapter 6, Trigonometric Identities. We're looking at the sum, difference, and double angle identities. This is Part 1. And we're going to be simplifying trigonometric expressions using the sum, difference, and double angle identities. So again, this is from Section 6.2. And the focus again is going to be on simplifying trig expressions using your sum, difference, and double angle identities. Let's quickly review what those identities are. Your double angle identities are sine 2a equals 2 sine a cosine a. The double angle identity for cosine, there are three different ones. Cosine 2a equals cosine squared a minus sine squared a. Cosine 2a equals 2 cosine squared subtract 1. Cosine 2a equals 1 minus sine squared a. And the double angle identity for tan 2a equals 2 tan a over 1 minus tan squared a. Some identities are sine of a plus b is sine a cosine b plus cosine a sine b. Cosine a plus b is cosine a cosine b minus sine a sine b. And the tan of a plus b is tan a plus tan b over 1 minus tan a tan b. And of course we also have the difference identities. Sine a subtract b equals sine a cosine b subtract cosine a sine b. The cosine of a subtract b, cosine a cosine b plus sine a sine b. And finally the tan of a subtract b, tan a subtract tan b over 1 plus tan a tan b. Although this particular lesson focuses mainly on your double angle identities, your sum of difference identities, you still need to remember your Pythagorean identities that were done earlier. Sine squared plus cosine squared equals 1. Cotan squared plus 1 equals cosecant squared. And 1 plus tan squared equals secant squared. All of these identities that you see here will be given to you on your public exam. So you no need of memorizing any of these. They're all given to you. And it's just a matter of being able to apply them correctly to different scenarios. So let's have a look at simplifying some. Let's take this one first of all. I got tan 116 plus tan negative 26 degrees divided by 1 minus tan 116 times the tan of negative 26. And you see over here I've written up in the corner for us one of the identities. Rather than having to go back and look for it, I've simply placed it up here in the corner. We know that the tan of a plus b is tan a plus tan b over 1 minus tan a times tan b. If you look closely at the expression that you see here, we can see that a is 116 and b is negative 26. So I can rewrite this as the tan of a, which is 116, plus, gotta be careful here, negative 26. Which simply becomes the tan of 116 subtract 26, which of course is 90. So I get the tan of 90. The tan of 90, if we use our unit circle to answer that, we could use our calculator, I suppose, but we'll use the unit circle. The tan of 90 degrees is located here. Of course, the tan of 90 is equal to sine of 90 over the cosine of 90. The coordinates of that point, of course, is x is 0, y is 1. The sine of 90 is 1, the cosine of 90 is 0. 1 divided by 0 is undefined. So because it's undefined, the solution is actually the empty set. So the solution to this first equation is the empty set. It's undefined. It doesn't exist. And notice we did use one of our sum identities for tan. Example 2. Which expression is equivalent to sine 2b over 2 sine squared b? Again, as soon as you see the sine 2b, you need to recognize that's a double angle identity, and I need to replace the sine of 2b with 2 sine b cosine b divided by 2 sine squared b. Simplifying this, 2 divided by 2 is 1. I get a sine divided by a sine squared. I can cancel 1 sine in the numerator with 1 sine in the denominator. That will leave me with 1 sine b in the denominator. So I'm simply left with cosine b in my numerator, and in my denominator I'm left with sine b. Cosine divided by sine is cotan. Correct answer is B. So all we're doing is simplifying expressions that involve these different identities. Here's another example. Again, at this point, you may want to pause the recording and try this on your own before I actually do it. Okay, 5 cosine squared A minus 5 sine squared A times tan 2A. You need to recognize here that this looks something like this. Cosine 2A equals cosine squared A minus sine squared A. But I got 5 cosine squared A minus 5 sine squared A. So if I remove a common factor of 5 here, I can rewrite this as 5 outside of cosine squared A minus sine squared A. And I'm just going to leave my tan 2A as it is for now, because this may actually work out whereby I wrote it in here for you, but we may not have to use it. Cosine squared A minus sine squared A is cosine 2A. So I'm going to rewrite that as 5 times the cosine of 2A times the tan of, I was going to write tan squared, but it's tan 2A. Fix that. And what I'm doing is I'm looking at my answers here and I'm trying to figure out how am I going to get one of those answers. I want you to notice that your answers are all in terms of 2A. That's why I decided to leave my 2A as it was. My tan 2A, I left it like that because my answers are all in terms of 2A. If I had seen something else here, I probably would have rewrote my tan 2A using this and rewrote my cosine 2A as one of these. But I can see that the answer is going to be in terms of 2A, so I think this can work out pretty nice here. I got 5 times cosine 2A times tan 2A, tan is sine over cosine. And when we multiply all of this together, my cosine 2A in the numerator will cancel with the cosine 2A in the denominator. I'm left with simply 5 sine 2A. Correct answer is C. Here's example 3. Example 4. I got 1 plus cosine 2x over cotan x. Now, I'm going to need to replace cosine 2x here with one of these 3 identities that I have for cosine 2a. I need to make a decision which is the right one to substitute in here. Oftentimes you need to look at the expression, and oftentimes there are hints in the expression as to which one of these 3 would suit best when I substitute it in. And the fact that I've got a 1 plus here is going to help me because I know that I got 2 over here with 1s in them. So if I'm going to add something with a negative 1 or a subtract 1 to a positive 1, that's going to cancel. So I will get rid of this plus 1 if I replace cosine 2a with this expression because I know I'm adding a minus 1 to it, or a negative 1 or a subtract 1. So I'm going to rewrite this as 1 plus 2 cosine squared x subtract 1 over cotan x. And again, you see now why I did this. I did this because of the fact that my 1 and my subtract 1 will cancel to give me 0. So I'm simply left with 2 cosine squared x over cotan, which is cosine over sine. Now I need to rewrite that 2 cosine squared x divided by cosine x over sine x, which becomes 2 cosine squared x multiplied by sine x over cosine x. You should recognize again that things will cancel here. I can cancel a cosine x with a cosine x, leaving me with a cosine x in the numerator, and I'm simply left with 2 cosine x sine x. Now I'm looking up and I'm seeing that answer is not there though. 2 cosine x sine x is not there. But you should recognize that 2 cosine x sine x is actually equal to sine 2x. Correct answer is C. Again, that's just another identity. Your double angle identity for sine 2x is equal to 2 cosine x sine x. So I just rewrote it back from this to this to get my identity of sine 2x. And there's number 4. Next example, which is equivalent to sine x plus 3 times cosine negative 3, subtract cosine x plus 3 times sine negative 3. Now, I'm not going to rewrite this using my sum identity for sine. I need to look at this and realize that I have sine, cosine, cosine, sine, separated by a subtraction sign. So if I look at my two possible identities for sine, I got a sine, cosine, cosine, sine right there, and I've got a sine, cosine, cosine, sine right here. Same thing here, sine, cosine, cosine, sine. But I would have a subtraction sign between the product here and the product here. So over here, which one of these have a subtraction sign between them? And it's this one here. So I can rewrite this expression using the sign of a subtract b. But rather than a, of course, I've got x plus 3, and rather than b, I have a negative 3. So I can actually rewrite this as the sign of x plus 3 subtract, very important to subtract, a negative 3. Be careful with that. So it gives me the sign of x plus 6. Correct answer is A. Sign of x plus 6. That was a little confusing because some students may want to immediately rewrite this using their sign identity for your sum identity for sine. But you don't want to do that because you need to look at this and realize that it's sine, cosine, cosine, sine, right? So it is already written as a sum identity. I just need to rewrite it as the sign of a plus b or the sign of a minus b. And the fact that there's a subtraction sign right here tells me that it's the sign of a subtract b. Of course, a is x plus 3, right? There's a, a. B is a negative 3, and a negative 3. Cosine b, sine b. So you hopefully can see the relationship between these two. So when I rewrote it as the sign of a plus b, or a minus b, sorry, it becomes x plus 6. Okay, one more example here, which is equivalent to the cosine of pi over 2 plus x, subtract the cosine of pi over 2 subtract x. Now in this case, I do need to rewrite this using my sum identities and my difference identities. I'm going to rewrite this one using my sum identity for cosine. I'm going to rewrite this one using my difference identity for cosine. What's critical here is this subtraction sign. We need to be very careful with that one. Let's do this. Cosine of a plus b is the cosine of a, so we're going to write that as the cosine of pi over 2 times the cosine of b, which is the cosine of x. Subtract the sine of a, which is the sine of pi over 2, times the sine of b, which is the sine of x. So I have this, subtract, very important that I put these brackets in, the cosine of pi over 2 subtract x. The cosine of pi over 2 subtract x becomes the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. All I need to do now is simplify this. And I know they look pretty complicated, but the reality is this works out pretty nice. Because we're looking at the cosine and the sine of pi over 2. Pi over 2, of course, using the unit circle, it's right here, 90 degrees. Coordinates of that point is 0 and 1. We know that the cosine of the point is 0. The sine of the point is 1. So the cosine of pi over 2 is 0. So I got 0 times cosine theta, or cosine x. Subtract the sine of pi over 2, which is 1, times sine x. Subtract the cosine of pi over 2, again, is 0, times cosine x, plus the sine of pi over 2, which is 1, times sine x. Of course, 0 times cosine is 0. I got a minus sine x, subtract 1 sine x. That gives me a minus sine x, and a minus sine x is a minus 2 sine x. Minus 2 sine x. Correct answer is D. You have to be very careful with that one, especially with the subtraction sign right here. If you didn't place the subtraction sign in here correctly and put brackets around this, most students would have rewritten that and possibly gotten 0 for the answer rather than a negative 2. Be very careful with the fact that you're subtracting all of this. Okay, key ideas again. You can use sum difference identities to simplify expressions and determine the exact trig values of some degrees. And again, there are your identities again. The sum difference identities are all going to be given to you. And of course, same thing with the double angle identities. The double angle identities are special cases of the sum identities when the two angles are equal. The double angle identities for cosine can be expressed in three forms. There it is. And there's your double angle identities for sine and tan. Okay, that ends this lesson.